we have a soccer ball which is kicked into the air with an initial velocity of 40 meters per second. And this velocity makes an angle of theta equals 30 degrees to the horizontal. The task is for us to find the initial horizontal velocity and also the initial vertical velocity of this kick. So for two-dimensional motion problems, first, let us draw our coordinate system. Since we have two dimensions, we need two axes, one representing the vertical motion, which is our y-axis. Next, this ball is going to travel horizontally, so we need a horizontal axis. So with this, we have our x-axis. So that gives us the change in position of the ball along the x direction. That is giving it some range. So if we place the origin here, then it means we can place the ball at this location as a point. So it is kicked with some initial velocity, which is a vector quantity. So a vector quantity represented as v naught. So we know this ball is going to travel in a trajectory that is parabolic until it hits the ground. All we are interested in is to determine this initial horizontal speed or velocity which moves the ball horizontally, and then the initial vertical speed which moves the ball vertically upwards. So this initial velocity v naught is making an angle of theta with the horizontal. So we have this angle theta, and from the problem we are given v naught to be 40 meters per second and the theta, which is the angle, to be 30 degrees. Now if you look at this vector, you can decompose it into a horizontal and vertical component, right? So this vector is going to have this horizontal component along the x-axis. So from here all the way there, we will have the horizontal vector. We can call that v naught x. And then we are going to have a vertical one, which is from here all the way up there. We can call that v naught y. All right, so that is the vertical component. So our task is to find how much of this v naught, 40 meters per second, is v naught x, and how much of this v naught is v naught y. If you look at this vector, v naught, we have resolved it into the horizontal component and the vertical component. So we have a right triangle. So with this two vectors making a right triangle, this becomes the hypotenuse. We can apply trigonometry, which relates this angle to any two sides of this triangle. We can also apply Pythagorean theorem, which relates all the three sides. So let's see how to use trigonometry to determine v naught x, which is the horizontal component, and v naught y, which is the vertical component. And if this is the angle of interest, that is the angle this vector makes with the horizontal axis, then it is facing this side. So v naught y becomes the opposite side, and then v naught x becomes the adjacent side, and v naught remains the hypotenuse of this triangle. All right. So applying trigonometry, very straightforward. If we want the adjacent, we apply the cosine. So the cosine of the angle is the adjacent, in this case v naught x, divided by the hypotenuse, in this case that is our v naught. So with this, we know that v naught x is going to be v naught cosine of the angle theta. So if we have v naught x is equal to v naught, in this case 40 meters per second, and then multiplying the cosine of the angle, so cosine of 30 degrees. So we can simplify this to have 40 meters per second, and then with the cosine of 30, make sure if you are using a calculator, your calculator is in degrees, okay? So cosine of 30 is going to be 0.866, and it has no unit, right? So the unit comes from the 40 meters per second. So v naught x is going to be 34.6 meters per second. So this gives us the initial horizontal velocity, which is 34.6 meters per second. So to find the initial vertical velocity, that is v naught y, in this case, that is the opposite side of this right triangle. If you want the opposite side, we can use sine of the angle theta is equal to the opposite side, which is v naught y, and then divided by v naught. So again, we can isolate v naught y to be equal to v naught sine of theta. So we have v naught y, which is the initial vertical component of the velocity, is 40 meters per second, and then multiplying sine of 30 degrees. We are going to have 40 meters per second multiplying sine of 30, again, is 0.5. That is 1/2. So that means v naught y is nothing but 20 meters per second. So the initial vertical velocity is nothing but 20 meters per second. All right, so we have that to be 20 meters per second. So this, we can prove that if you apply Pythagorean theorem, that is v naught x squared plus v naught y squared should be equal to v naught squared. Can you check that and leave a comment in the comment section below? Until then, I'll see you in the next one.